Hey, Ryzen here. In this video, we'll build a decentralized React application that enables users to purchase Bitcoin using EVM-compatible blockchain assets. We'll leverage Ryzen Kit as our foundation, providing a robust TypeScript monorepo setup equipped with extensive utilities and reusable components for efficient development. To enable the swap from EVM-compatible assets to Bitcoin, we'll use THORChain, a cross-chain liquidity protocol. Simply send your token to a THORChain address with a specific memo indicating the swap details. THORChain then automatically executes the trade through its multi-chain liquidity pools, returning native Bitcoin to your wallet. No intermediaries or rope tokens required. Working with ERC20's tokens adds complexity since it requires obtaining user approval for token spending. To keep this tutorial focused and manageable, we'll concentrate solely on native EVM assets. THORChain supported networks can be determined by querying its pool's endpoint. Currently, THORChain supports 3 EVM-compatible chains: Ethereum Mainnet, Binance Smart Chain, and Avalanche. We define these chains in our application and create a chain ID type from this array. The getChain utility function allows us to retrieve chain information using its numeric identifier. To enable users to swap their assets for Bitcoin, they first need to connect their wallet to our application. We'll use RainbowKit, a popular wallet connection library that provides a polished user interface and seamless integration with WAGMI, the leading library for interacting with EVM-compatible chains in React applications. This combination offers a robust foundation for handling wallet connections and blockchain interactions. The WAGMI provider configuration includes several key components: our application name, a project ID obtained from Wallet Connect for enabling mobile wallet connections, and the list of supported blockchain networks. For each supported chain, we configure a transport layer using HTTP clients that facilitate communication between our applications and their respective blockchain networks. Our application is roped in a query client provider for 2 key purposes. First, it supports WAGMI internal data fetching needs since WAGMI is built on top of React Query. Second, we leverage the same query client to efficiently fetch and manage data from the THORChain API. Additionally, we include the wallet provider component within this wrapper to handle wallet connectivity throughout our application. Our application consists of a single page that serves as the main interface for the Bitcoin swap functionality. We configure SEO-friendly meta text for the title and description to improve discoverability. Since the page content is dependent on the user's wallet connection state, we've roped in a client-only component to ensure proper client-side rendering and prevent hydration mismatches that could occur with server-side rendering. The wallet guard component ensures users are connected to their Web3 wallet before accessing protected content. It automatically displays a connect wallet prompt if no wallet connection is detected, providing a seamless authentication flow. Once connected, the guarded content becomes accessible. The connect wallet components provide a user-friendly wallet connection interface. It displays the product logo at the top and a customized RainbowKit Connect button below. By using Connect button custom, we are able to maintain consistent styling with our application design system through our own button component while leveraging RainbowKit's robust wallet connection functionality. Users can disconnect the wallet by clicking the exit button located in the top right corner of the navigation bar. This button leverages the use disconnect hook from WAGMI to safely terminate the wallet connection and reset the application state. The centered content column utility function from Ryzen Kit provides a flexible solution for centering content on a page. It creates a responsive 3-column grid layout where the middle column contains your content and automatically adjusts its width based on the viewport size. The function ropes the styled component CSS helper and accepts parameters to customize the maximum content width and minimum horizontal padding, ensuring consistent spacing and optimal content presentation across different screen sizes. To manage the user's transaction detail, we implement 3 state providers using React Context API: THORChain ID provider for storing the selected blockchain network, address provider for managing the destination address, an amount provider for handling the transaction amount. These providers wrap our application content and make the states globally accessible to child components. RisonKit includes a getStateProvider setup utility function that streamlines the creation of React context providers for managing single values. This utility eliminates boilerplate code by automatically generating a provider component and a custom hook for accessing and updating the state. The chain selection dropdown is implemented using RisonKit's select option input component. This component renders a customizable drop-down menu that displays our supported blockchain networks. Each option in the drop-down combines a chain-specific icon with the chain's name, creating a clear and intuitive selection interface. For handling asset amount input, we utilize RisonKit's amount text input component. This component provides a user-friendly interface for entering numerical values. The input field is enhanced with a clear label that dynamically displays the selected asset's name, making it immediately obvious to users what type of value they're entering. The max amount component provides users with a convenient way to view and utilize their maximum available balance for swaps. It integrates with the wallets through WalkMe's useBalance hook to fetch the current balance, then displays this information as an interactive suggestion within the amount text input. Users can click this suggestion to automatically populate the input field with their maximum available amount. Currently, setting the maximum amount for native token transfers is not very practical since users need to reserve some balance for gas fees. However, this feature will become more useful when we implement ERC20 token swaps, as users can send their entire token balance without needing to reserve any for gas. The match query component from RisonKit allows us to conditionally render content based on different query states. In this implementation, we only render the max amount suggestion when the balance query succeeds, since displaying this feature is not crucial to the core functionality. If the query is an error or loading state, nothing will be shown, which is acceptable for this optional UI element. The final input field allows users to enter a destination Bitcoin address using RisonKit's text input component. While Bitcoin address validation would enhance security and user experience, it has been intentionally omitted from this implementation to maintain a focused scope. The final component of our form is the swap quote component. This component leverages match query to handle different states of the quote request. Unlike previous implementations, we explicitly handle both pending and error states to provide clear feedback to users. The pending state shows a loading message, while errors are displayed prominently to help users understand and resolve any issues that arise during the quote process. To optimize the quote fetching process, we utilize useStateDependent query from RisonKit. This hook creates a query that depends on both the address and amount states, ensuring that quotes are only fetched when both values are provided by the user. This approach prevents unnecessary API calls and provides a more efficient user experience. The getQuote function is responsible for fetching swap quotes from the THORChain network. It takes three parameters: address, amount, and chain ID. The function constructs a query URL with these parameters and makes a request to the THORChain node's quote endpoint. The response includes important swap details such as expected output amount, fees, inbound address, and memo required for the transactions. If the response contains an error, we throw that error. Additionally, if the recommended minimum amount from THORChain is higher than the user's input amount, we throw an error with a formatted message showing that minimum required amount in the user's native currency. Upon successful response from THORChain, we render the swap info component to display the estimated Bitcoin amount the user will receive. While we could display additional data like network fees, exchange rates, and USD values, we'll focus on showing just the output amount to keep the UI clean and straightforward. The component formats the Bitcoin amount using the correct decimal precision and add the BTC symbol for clarity. For seamless network switching, we implement the chain guard component. This component checks if the user's wallet is connected to the correct blockchain network. If there is a mismatch between the user's current chain and the source chain selected for the swap, it displays a button prompting the user to switch networks. This ensures transactions are always initiated from the correct blockchain network, preventing potential errors. The execute swap component handles the critical task of executing the swap transaction between networks. It leverages WAGMI's useSend transaction hook to initiate and manage the transaction flow. The component provides a seamless user experience by displaying real-time feedback showing a success message with a THORChain transaction link upon completion, or a clear error message if the transaction encounters any issues. The component accepts a memo and a receiver address as props, which are essential for routing the transaction through THORChain's network. This tutorial has shown how to build a decentralized application for swapping EVM assets to Bitcoin using THORChain. Using Radeon Keys component, we've created a user-friendly interface that handles wallet connections, network switching, and transactions. The application focuses on native token swaps while maintaining a clean UI that guides users through the process. Users can confidently exchange ETH, BNB, or AVAX for Bitcoin in a trustless way. If you found this video helpful, please like it and subscribe to the channel.